Hello viewers, today again I am with you, myself Dr. Amitabh Sarkar from Durgapur Ishwar Chandra Vidyasagar Public High School. Today I am going to discuss one important topic, which stone bridge principle, by which you can able to find out the resultant resistance of the combination. So, Wheatstone bridge principle, it consists of 4 resistance and 1 galvanometer. Basically, it is based on the principle of Kirchhoff's law. The principle is, if the ratio of P by Q is equals to R by S, then no current will flow through the galvanometer. That is, the current through galvanometer, that will be 0. So, means the principle is, if the ratio of P by Q and the R by S is equal, then no current will pass through the galvanometer, neither from C to D nor from D to C. So how we can able to prove this one? So let us prove that formula. So if we consider I is the current flows through A, then along this direction, suppose this is I1, and through R, suppose the current is I2. When the I1 will reaches at point C, it will divide it into 2 components. Along the galvanometer, suppose I suffix G is flowing along the downward direction, and the remaining current that will pass through the Q resistance will be I1 minus I suffix G. And when it will come down to D point, and along this direction the I2 will reach at point D, then these two will join together, and the total current becomes I2 plus I suffix G. Again at point B, they will join together and again becomes I. Means within this diagram we are having 2 loops. This is the loop number 1 and this is the loop number 2. Now for the first loop, that is loop 1, I am considering A, C, D and A. So for this loop it will be I1 into P, that is the potential drop across the P resistance, plus I suffix G into G, this is the potential drop across the galvanometer, and then minus I2 into R. Why I am writing minus? Because I have taken the loop from A to C, C to D and then D to A, but current actually flowing along A to D, that is minus IR is equals to 0, because within this loop no cell is there. Now if I suffix G is equals to 0, that is if I consider no current is flowing through the galvanometer, means this part will be 0, that is I1 by I2. If we take the ratio, it becomes R by P, and you can take it equation 1. So again I am repeating what I have done. I have taken one loop. So this is the name of the loop I have given 1. So for this loop I have written one equation by following the Kirchhoff's voltage law, that is potential drop across P, potential drop across G, potential drop across R. The sum is 0 because within this loop no cell is there. Similarly, if we consider the loop 2, that is any direction, either you can take it C, B, D, C, or you can consider C, D, B, C. So anyone we can consider. So take it C, B, then D, then again C. I am starting from C and I am ending to C. That's why it is called loop. Now within this loop I have taken from C to B. Current is also flowing along this direction. So it will be I1 minus I suffix G into Q, because potential drop is current into resistance, plus when I am moving from B to D, but actually B to D means current is flowing in the opposite direction. So that's why instead of plus you have to write minus, and then it will be I2 plus I suffix G into S. And Similarly, when you will move from D to C, it is in the opposite direction of flow of current. So again I am given minus, and then I suffix G into G, again this equals to 0. So this is the equation that also I have got from the Kirchhoff's voltage law, and if we consider I suffix G is equals to 0, means this equation becomes I1 into Q because Ig is 0, minus I2 into S, minus this part will be the 0 is equals to 0. That is I1 by I2, that will be equals to S by Q. So make it equation 2. What I have done, I have taken the first loop. From the first loop I have got one relation, I1 by I2 is equals to R by P. And from the second loop I have got another relation, I1 by I2, that is equals to S by Q. So from equation 1 and 2, what I am getting, that I1 by I2 in the left hand side and the right hand side another part is there. So that P, R, S, Q all are resistances. So if I equate equation 1 and equation 2, so I am writing here, equating 1 and 2, that is equation 1 equal to equation 2. So if I equate these two, then it becomes R by P is equals to S by Q. So you can change it, you can write it down as P by Q is equals to R by S. Clear? So see, I have got this principle. So if the ratio of P by Q is equals to R by S as said, then no current will flow through the galvanometer. But I have proved it in reverse way, that if no current flows through the galvanometer, then the ratio will be same. So this is the Wheatstone bridge. Mainly this Wheatstone bridge is used to find out the equivalent resistance. Second one, the main application is the meter bridge. So that one I will do in the next class. Thank you.